All right, welcome to this session. So we are actually proceeding on to question four. We want to look at some chemical reactions, want to see how we can go about reaction mechanisms, and we want to see how we can give answers to the questions that were there. So it's saying, the question is saying, predict the major organs, predict the major organic products from each of the following reactions. So let me just share first of all the let me first of all share the questions with you. But anyway, it's fine. I'll just write down the questions so that we can have a better overview of what we'll be talking about. So let's proceed.
Okay, we have a compound which looks like this, a five ring structure. Uh, okay, hydrogen and a double bond. So this one was reacted with this. Okay, in presence of an acid, sulfuric acid. So ethyl, this is ethyl. Ethyl is just a protecting group which protects the aldehyde. Okay, so once it reacts, it will form the product which looks like this. Okay, um, okay, going to have that. So the hydrogen here, so the thiol reacts like this. It breaks this like this and adds the oxygen. Then it covers on top. So this you have predicted the product for part A. Then let's move on to part B. Part B saying um okay, you have a ring structure. It's like this. Okay, it's like an aldehyde and an alcohol here. Okay, then you have a double bond, double bonds there. So this one was only reacted with the sulfuric acid. Maybe we can show the mechanism for this reaction. Okay, so the mechanism for this reaction will be, first you see an acid, there will be protonation. So you're going to protonate. We're going to protonate the, can I show the, okay, I'll just show it here. We know it's sulfuric acid, right? It's like that, in that form. Mm, okay, so we'll protonate this oxygen, gets the hydrogen there, and we have the compound which looks like this. Okay, alright. Um, like that. We'll protonate. We have just protonated that. Then here the alcohol it is. So what is going to happen? These lone pairs on the oxygen, there will be an intramolecular reaction. So this will come and attack here, hence breaking the bond to the oxygen. Okay, then if we break the bonds to the oxygen there, we are going to form this compound. Okay, this is the compound we're going to form, like that. Here there is a hydrogen. Here now it's no longer an aldehyde, it's an alcohol. Then on the same carbon we are going to attach the alcohol which came to attack there, something which looks like an epoxide. Then this has a hydrogen. Remember we used sulfuric acid. The remaining of sulfuric acid was looking like this. With lone pairs of oxygen. So these came to get the hydrogen and the lone and the electron for on the oxygen. Then the final product will be this. The final product. Oh, okay. And look like this. Able to show the hydrogen there to show that this was a secondary alcohol. Yeah. So and the double bonds inside the ring. So this is the structure which we have formed as our B. Then let's move on to C. C, we had an epoxide in such a form. Oh, yeah, C was this. Not an epoxide, sorry. Wanted to skip a question. Yeah. Okay. It's an alcohol also here. Then reacted with a ketone. A ketone in presence of sulfuric acid. So before we even go to this alcohol, the alcohol here, we'll protonate the ketone. Protonate it. Under protonation, the hydrogen comes to attack, is attracted by the oxygen. The hydrogen is attracted there. Yeah, I'm sure you know the general idea. Yeah, it will be like this. Like that after protonation. So now this one, we can use now the alcohol which is here. We can use this or this, but we would prefer going for the terminal one because it has a lesser hindrance compared to the one in the middle. So use the one what's the terminal part here to come and attack. So it's this one with these two lone pairs to come and attack here, breaking the bonds to the oxygen which is positively charged there. Hence, okay. Okay, let's reduce the size. Yes, here we're able to see it in one. Okay, so once we attach there, we're going to form a product which looks like this. So just draw the way we see it. Okay, so we'll start with the ketone there. The double bond has broken. We have an alcohol now. Then here, down here, we have an oxygen which is having an hydrogen, and this oxygen is bonded to how many carbons? 1 2 3 4. 1 2 3 4. So this is it. So now we got the hydrogen from sulfuric acid, and this oxygen is now positively charged, so we can come and deprotonate the Okay, we have forgotten the oxygen, the hydroxyl on the carbon number 2 there, carbon 1, carbon 2 here. So here we have it. Yeah, thank you very much. HSO4 minus. So this one come under, gets the hydrogen, then the electron comes there. Hence our final product will draw its property now. It will be, okay, see, start drawing the one down there. It should be, okay, no, it's fine. 1, 2, 3, 4. On carbon number 2 we have this. So this is our product we have formed. Yes. Then let's move on to question D. Now D, yes, can do D, the epoxide one. um, the epoxide. Okay, this is the epoxide. First reaction is reacting it with the sulfuric acid. So this is be just the opening of in presence of water, a first step. So there will be protonation. Whenever you see an acid, there will be protonation there. So these lone pairs on the epoxide will come and gets the hydrogen from there, and you have something which will look like this. Something looking like there. Yeah. Okay. Then water will come in now. The water will come in to come here and open the ring there. So we have a compound which is looking like, okay, let's draw the compound straight. Okay, so it will open. Now we are going to have 1, 2, and OH there, 1 to the OH. Yes, plus now at this point we are going to have another said step 2. They reacted again with this looks like an aldehyde, in presence of an acid as a catalyst, sulfuric acid. So this is going to protonate. Still, this one comes there, and you're going to have this oxygen positive with a hydrogen after protonation. Then after this takes place, you have the oxygen here, which is negatively charged. It will come and attack there, opening this double bond. Wow. Okay. Yeah. The products in a systematic way. Okay. We are going to have the structure which will look like this. Let's draw the way we see it. So here the bond breaks. We are going to have an OH. Then here there is an oxygen with a hydrogen there. The oxygen bonded to that carbon, this carbon. Then we have a ring structure, which is this. Now this oxygen becomes a positive charge because of the hydrogen. So now the acids we deprotonated at the first step, which is H. Okay, let me use another color for the acid. Okay, HSO4 minus. So this minus comes to get this, and the electron falls there. Hence our product will be this. We'll draw the way we see it. Then this oxygen can be either be here like that. Voila, you have the products. Then let's go on to part B, part 2 of this question. It involved some part 2 of question 4 Um, for the following reactions, provide the final products of the reactions. We want to provide the final products for each of these. So the structure is looking like this. Then at the first point, we're going to react it with 1, 2, 3, okay, 3, 4, okay, MgBr in excess with this, the protected group. Okay, so once we react with this, what is going to happen? Carbon here will come and attack from here. Okay, okay. Okay, let me show I'll show that these are reagents. So the carbon here comes all the way to attack here, and breaks off there. Hence, okay, it's increased here. Okay, hence we are going to have a structure which looks like this. Oh, 1, 2, we'll draw the one. Yes, there is a hydrogen here. We have broken the O there, which will have a negative. Then this, which is a 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. On carbon number 4, which is 1, 2, 3, 4. Okay, here it won't look nice. Let me draw it faces the up, so that don't confuse the structures. Okay, the hydrogen. Okay, so we have the oxygen there, which we broke. Then we're going to count the 5 carbon which have been added. 1, 2, 3, 4, 5. Yes, 1, 2, 3, 4, 5. On carbon number 4, we have this. Yes, so this is the structure on the first point. Then the second step was to add an acid or a proton. So a proton was added. Second step, proton, which is HO3. Okay, so there will be this oxygen, which is negatively charged, will come and will be deprotonated by the acid. Yes, this will take place, then the electron will fall there. Then we are going to have our compound as okay, see the compound there. Right, 2 oxygen there. Okay, then here is to come OH. Then 1, 2, 3, 4, 1, 2, 3, 4, 5. Then on carbon number 4, here we had the thiol functional group. Upon adding an acid, if you add an acid, it gets back to a ketone here. It's not a ketone. We had did we have a hydrogen this side? No, it didn't have, so this is a ketone. So if it was an H, it would be an aldehyde. So this is the structure we are going to form after we add an acid. Then they didn't end here, they continued, proceeded to say we had another step. This was added now with a Jones reagent. A Jones reagent, chromic acid, or 4. So this chromic acid, it converts, the Jones reagent will now convert the alcohol, a primary alcohol, to an aldehyde, and the secondary alcohol into a ketone. So that's what we are going to have here. So we have here an alcohol, the alcohol part here, which is here, the secondary alcohol, will be converted to a ketone by this reagent, and our product will be just a ketone. Writing a ketone, it will be 1, 2, 3, 4, 5, then there it's down. So here where we had this is a hydrogen. If you want, you can remove it. We're going to have a ketone, and here a ketone. If you don't want, you can show the hydrogen. Actually, it's just making confusions here, and draw properly the structure here. I say, okay, on carbon number 5, okay, start counting as 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So on carbon number 6, we are going to find another ketone. Then on carbon number 6, there is a branching of an oxygen and an ethyl there. There it is. So this is a well structure for this compound. Okay, move on to B. Oh my god. Is it B or C? B, yes. Okay, it's B. Oh, it was one of these interesting questions. Okay, we have 2, 3. 1, 2, 3. Okay, with an OH there and another one there. 1, 2, 3 with OH there. So this was also just reacted with an acid. Was reacted with an acid. So you can use any acids here: sulfuric acid, hydrochloric acid. So whenever we see an acid, all we need to hear is a protonation. Now the question is, which alcohol are we going to protonate? Are we going to protonate? Oh, sorry. We are going to protonate the ketone. The ketone will be protonated at, then okay. So after protonation, the structure will look like this. This is just an intermediate. 1, 2, 3, 4. Okay. With a hydrogen there. 1, 2, 3, 4. Okay, so we have this. So here we are going to have an intramolecular reaction either from this oxygen or the down oxygen down here to attack the carbonyl here, the carbonyl here, use another color. So we can attack either, because they are all equal from the ketone, they are one carbon away from the functional group, and they have same number of carbons. It has 3, it has 3. So either of these can attack, and we'll show the product for either. So how is it going to attack? It is this oxygen which will come and attack there, breaking the bond there. If we attack from that side, we'll have a star which looks,
we had made the edge. Now, this is a 4 carbon, a 3. It's 1, 2, 3. Okay, 3 carbons. So we are going to have 1, 2, 3. Mind you, we and yes, sorry, let me draw its property. It needs to come and attack on the carbon which is here. Yeah, it's just fine here. So this is the structure. Our structure we are going to have, yeah, like that, with an OH which we formed here. It just came and folded itself here. So if we did it from this other way around, we'll show it in which other color is here, red, blue, red, this one, green, white. Okay, there's white. Someone wants white. Okay, alright, so draw just down here. Okay, Okay, in presence of an acid, we just showed as a catalyst. So whenever there is an acid, protonation will take place. So protonate. This one comes to take the hydrogen, then the conjugate base leaves. So hence we are going to have a structure looking more like this. Then the nitrogen, we'll draw it like this. 2 hydrogens there and the lone pairs. then the double bond there with a hydrogen, then this one becomes positively charged with one lone pair of electron. So what is going to happen, the negative on the nitrogen, the electronegativity on the nitrogen and the carbon here becomes partially positive and this one is negative, so it will come and attack an intramolecular reaction. So this one comes here to attach and breaks the bond here. Hence we are going to form a structure which looks like this. Okay, here we have 1 2 3. We have a nitrogen with two hydrogens, then this is bonded there with an alcohol here, HO. Now this one becomes positively charged, the nitrogen, because it's bound, now it's bonded to a lot of things. Remember we had a conjugate base here which we deprotonated, so the base will come, conjugate base, okay, the base will come and get one of these